Okay, so today our topic, today we have two topics. One is the how basin is formed, by what mechanism basins are formed, and we will also study today the types of sedimentary basins, the most famous and the most economical basin in terms of petroleum exploration. We will study the basin types, and I think we should start the lecture by now because almost everyone has joined. So the concept of basin, mechanism of basin formation. So can anybody tell me what are the mechanisms of basin formation? How basin is
Sir,
formed?
well, tectonic play main role, sir.
Yes,
Due to plate motions or plate movement,
yes, correct, very right.
basins are formed.
Yes, the only force or external force which is responsible to produce the sedimentary basin is plate motion. So plate motion is responsible for the formation of sedimentary basin. What are the types of plate motion? Can anybody tell me about the types of sedimentary basins? Sorry, type of plate tectonics.
Sir, three types mainly, sir.
Okay, name it please.
Convergent, divergent, and transform.
Okay, very right. So these three types of plate motions are responsible for creating, for changing the types of basin, for combining the different types of basin into one type, and also for disintegration of basins. So we will examine the basins according to their position with respect to plate boundaries and plate-plate interaction. Plate-plate interaction is the most important factor in basin formation, and it controls the basin structure. Plate-plate interaction, okay? So what are the major mechanisms for subsidence or uplift? Can anybody tell me what are the major mechanisms of subsidence? What causes the subsidence? Okay, the first one is isostatic changes. Changes in crustal or lithospheric thickness or angle or bending of strata. So what does it mean? Okay, this is the changes in the crust, upper crust or lithosphere, or even you can say that asthenosphere. How the crust changes. For example, we take the first one, thickness. How the changes thickness in a basin? The changes thickness by addition of sediments into that layer. Which layer? The uppermost layer, which receives the sediments from the mountains, from the volcanoes, from the volcanic piles. These are the bodies which add the crustal changes into the basin. That is, layer by layer, they are deposited into the basin. So which one is next one? Loading. Loading is another major mechanism for subsidence or uplift. By thrust sheets, volcanic piles, and sedimentation. Can anybody tell me what are thrust sheets? Okay, thrust sheet is a sheet-like body of rock that has been moved more than 2 kilometers. Whatever I say in the lectures, everyone has to note it down on the notebook because you are now in a master's level student. So when you are master's student, spoon feeding will not be done here. So you have to note down whatever I say in the lecture. So what are volcanic piles? Can anybody tell me about the volcanic piles? Okay, volcanic piles are those magma or lava material that is erupted by the volcanoes, and it is placed on the top or sides of the volcanoes. These are called the volcanic piles. And after that, in loading is sedimentation. As you already know, and I have already told you that sedimentation starts from the mountain and it is transported by several factors that can be wind, glaciers, or any type water. So they are then deposited in the basins. These are parts of loading. So what one? Which one is the third one? Dynamic effects in mechanism for subsidence or uplift. It includes asthenosphere flow, mantle convection, and mantle plumes. So what is asthenosphere flow? Can anybody tell me? Everyone is hearing
For
me or
example,
not?
semi-solid. Yeah, yes, I am hearing others about.
Okay. So what is asthenosphere flow? Can you repeat?
सर ये दिनोस्फीयर जो सेमी सॉलिड बॉडी होती है ये कंटिन्यूस मोशन में होती है इसके ऊपर क्योंकि लिथोस्फीयर भी मूव करती है और ये भी स्लाइटली मूव करती होती है क्योंकि ये सेमी सॉलिड बॉडी होती है मंटल के ऊपर मूव करती है
Yes, very right. But it is not necessary for asthenosphere to flow always. It can be at rest, but it moves slowly and creepily. So then what is mantle convection? Mantle convection is the very slow creeping motion of Earth's solid mantle caused by convection. And what about the mantle plumes? A mantle plume is an abnormal movement of the hot rock that is melted and present in the subsurface, but its movement is abnormal. So when it is abnormal, movement is found in the magma or magma, it is called mantle plume. I will show you in the upcoming slides the figure of mantle plumes, how they affect the basin's formation. So we would like to start with the isostatic process in detail. Crustal thinning. How crustal thinning starts? Crustal thinning starts by the extension or stretching. So in which plate boundary crustal thinning starts?
Divergent.
Yes, very right.
डायवर्जन बाउंड्रीज
So can we say that erosion is also a type of crustal thinning?
Yes, sir.
Yes, very right. Okay, what about the magmatic withdrawal? What is magmatic withdrawal? Okay, never mind. We will discuss that in the figure. The next one is mantle lithosphere thickening. So what is mantle lithosphere thickening? Cooling of lithosphere following cessation of stretching or cessation of heating. What does it mean? How mantle or lithosphere is thickened? Lithosphere gets thickening from the magma material that erupts on the surface, and that material, when that material is added on the crust, that is called lithosphere thickening. Crustal densification. Density increases due to changes in pressure or temperature conditions, and our emplacement of higher density melts into lower density crust. What does it mean? Can anybody explain me about the crustal densification, how the crustal is densified? Okay, crustal is densified by adding an immense amount of large weight onto the surface of earth where the crust is. For example, we will take a real life example, that is fold and thrust belt of northern Pakistan. The immense weight of that has caused the sedimentary basins of Pakistan. How it forms? When the immense weight of the orogeny came into being, that weight causes the crust to crust, and it causes the subsidence in the upper crust. Loading by thrust sheets, volcanic piles, and sediments. Thrust sheets are associated with the fold and thrust belt that is called orogeny. In orogeny, most of the mountains have the thrust sheets. Volcanic piles, there in the previous times in Pakistan, when we have had the volcanoes, the volcanic piles has found on the surface of Pakistan. Local isostatic compression of crust and regional lithospheric flexure. What is flexure? Can anybody tell me what is flexure? What is the meaning of flexure?
Sir, bending or curving, we can say.
Yes. What else? The breakdown. We can say the cracks in the lithosphere. Flexure itself means curving, bending, or cracks or breaks in any material. So lithospheric flexure means the fractures that are found in the lithosphere depend on the flexure rigidity of lithosphere. So is there any rigidity in the lithosphere? Is lithosphere rigid?
Yes,
When
sir,
we
it is.
Yes, rigidity होती है उसमें.
when do we say that something is very rigid?
जब वो सर बहुत हार्ड हो और वो स्ट्रेच ना हो सके
Sir,
आसानी से
when
Yes,
या
when it is
बेंड
unable
ना
to
कर
bend,
सके.
sir, when it
yes,
is
very
unable
right.
to bend or uh, तो जिसकी
When
शेप नहीं हम चेंज कर सकते हैं जब काफी चीज हार्ड हो जाती है.
yes, it
नॉट
also
फ्लेक्सिबल.
yes, you can say that. When we say rigid, it means it is hard to bend in terms of lithosphere. So it is hard to bend. Why it is hard to bend? Because lithosphere is a solid body. It is not in a viscous form, and it is also not in a liquid form. So it is a rigid body in the subsurface in the surface of Earth. As compared to a asthenosphere, the lithosphere is very rigid body. Okay, tectonic loading during overthrusting. So we move on to the next slide. What are the dynamic effects? Asthenosphere flow. Descent are, so what is descent? Can anybody tell me what is descent?
सर टू
And
गो डाउन.
delamination? Sorry?
टू गो डाउन सर.
Yes, very right. And what is delamination? Breaking down.
सर टू राइज मे बी.
When we talk about the asthenosphere flow, it means the movement of asthenosphere downward towards the mantle, center of mantle. Then is the next one is the mantle convection and mantle plumes. So here is the figure. I wanted to show you this figure. So this one is the crust, right? So after crust, we have the asthenosphere, the semi-viscous material that is found on in the upper mantle. So what does this figure show? It is showing the movement of magma towards the surface, and it needs a weak area to come on the top of a surface, and when it erupts, it forms the volcanic piles. Here in the figure you can see here the volcanic piles are found when the magma erupts on the surface. that is called lava. So can anybody tell me that only magma is erupting on the surface, or it also contains a stenosphere material with itself?
Sir, it definitely contains stenosphere material because it is rising up and it melts the
Yes, not only stenosphere material, but it also dissolves in it the lithosphere, and it comes on the top of the surface. So it is also dissolving the crust material which is found on the top of a stenosphere. So now we can say that it is responsible for creating, adding, and dissolving the material that is found on the surface. Is it correct?
Yes, sir.
Yes, sir.
So the figure is clear, I guess.
G, sir.
Okay. So basins are classified and named on the basis of what? How we can classify and name a basin? Its position with respect to its plate boundary in which it is found, and nature of plate boundary. So these two are the factors on which naming of the basin is done and its classification is done. How we classify the basin. So which type of basin is this? Can anybody guess about this type of basin? And where is the basin?
Sir, trench basin sir left corner पे left side पे.
Okay. And what second type of basin
Trench
is
पे
found?
sir basin
Ford land basin just beside the mountains.
Which land basin?
Ford land, I guess, sir.
foreland
Foreland.
basin.
Foreland. Okay, what
Yes,
else you
sir.
see in this figure?
Four arc basin and Baker basin.
Okay, so what else you
Volcanic
see?
island.
Volcanic island. Okay,
Volcanic arc.
what type of plate boundaries are present here? What processes are present here? Can anybody tell me?
Oceanic
The
continent.
convergent plate boundaries.
Convergent.
Convergent
Okay,
plate boundaries.
so
Construction take place.
first one we take is the convergent plate boundary, and the second point is we found a trench basin in this one. What else we found on this figure?
Volcanic arc, sir.
Volcanic arc. Okay, what else? Is magma erupting on the top of the surface?
Magma.
Yes,
Is
sir.
there a subduction zone?
Yes,
Yes,
sir.
Yes, sir.
Yes, sir.
Yes sir.
Subduction zone is present. Sir, on the
Okay,
left side, sir.
okay, so is there any second type of basin that is present?
The Ford land basin.
Foreland basin. So okay, yes, this is a foreland basin, and we have two types of basin present here. One is the trench basin, and the second one is the foreland basin. So how the foreland basin was formed? Foreland basin was formed by the thrust sheets that came on the surface due to the immense amount and the huge mass of mountains that is also called orogeny. So when the orogeny builds on the surface, it causes the subsidence on its sides. It drags the surface on both sides of it with itself due to the immense weight. It causes the subsidence, and when that depression is formed by the mountains, that is known as foreland basin. So now, why it is called foreland basin? Because it is found on the land. And another thing, on this land, the basins, that depression I'm talking about, where the sediments will come in this basin. Can anybody guess from where?
From the mountain,
Yes,
volcanic arc,
yes, very right.
erosion of volcanic arc, sir.
Yes, it will get the sediments from the mountains, that is orogeny. The present day example I will give you is the Pakistan, and we also have the subduction zone in Pakistan. We also have the Himalayan orogeny. You must have heard it. And we also have the fold fold and thrust belt
Yes, sir.
in Pakistan. So is the figure clear to you?
Yes, sir.
Yes, sir.
Yes.
Is foreland basin clear to everyone?
Yes, sir.
Okay, so we move on to its definition. Foreland basin is formed by immense mass created by crustal thickening associated with evolution of mountain belt causes the lithosphere to bend by a process known as lithospheric flexure, that also known as bending of the lithosphere. The lithosphere flexure is the process by which the lithosphere bends under the action of forces such as weight of growing orogeny. Can anybody tell me how much Himalayan orogeny is building every year?
Sir, 4.5 centimeter per year, sir, the movement of plate, and orogeny speed 5 millimeter per year, sir.
Very right. The movement of plate is correct, and the Himalayan orogeny building depends on the movement of plate. So it varies, but the movement of Indian plate is 4 centimeter per year.
Yes,
So
sir.
this is also called isostasy. There are four types of isostasy. In the first figure, you can see that there is no isostasy. Isostasy means in here isostasy means the bending of lithosphere. In the first figure, you can see due to the less weight of the orogeny, there is no bending in the lithosphere. But in the second one, you can see there is a bending in the lithosphere. What can cause the bending of lithosphere?
Sir, load.
Yes, one is load, and second one, plate movement. How plate movement can cause the bending? Due to stretching of the plate boundary. Is it clear?
Yes, sir.
Yes, sir.
Okay, the third one is in the third figure, it is also known as regional isostasy. But what is the difference between second and third one? The difference is the lithosphere can bend in any direction. It is caused by the density and viscous asthenosphere. So now, when we are going deep, step by step, it is clear to all of you that plate motion causes the basin formation, basin changes in types. So what is the fourth type? Can anybody tell me what is the fourth type? Local isostasy. What happens here? It is purely caused by the subsidence of the asthenosphere or lithosphere. So these are the four types of isostasy. Number first one is no isostasy has taken place, and two other types of are regional isostasy, and the fourth one is local isostasy. So here is the figure. What is, can you see the figure?
Yes, sir.
Okay, so what these lines are representing? Can anybody tell me what these lines are representing?
Faults, fractures.
Okay, apart from faults and fracture, what these lines are representing? Is it a body of huge rock?
Bedding planes, sir.
The
Okay.
mountains,
Yes, sir.
they are
Bedding
existing
planes
mountains.
Sir,
proved.
mountains present, sir.
Yes. Yes, mountain is present, but is it a large body of rock material?
Yes, sir.
In the previous slides, what we called these large bodies?
Volcanoes.
Thrust sheets. These are called the thrust sheets.
कौन सी जगह से thrust sheet?
These are the thrust sheets. This
Okay.
one, this one, and this one. These are the thrust sheets.
Yes.
Okay, so what are the other points of Foreland Basin? Crustal loading of thrust sheet causes subsidence. It may face towards or away from continental interior. Ocean to continent or continent to continent collision. Rate of subsidence greatest adjacent to thrust loading. So can we say that Foreland Basin also occurs on the oceanic boundary? No, we cannot say that.
No, sir, because it is formed on the land.
Yes, it is only related to land. So the next figure, is it visible to everyone?
And that's why.
Yes, sir.
Okay, so here we have three types of basins in this figure. Starting from this point until this point, we have three types of basin. So first, I would like any of you to explain what is happening in this figure. Please point out what phenomena is going on, what processes are occurring in this figure, what type of boundary is there, what forces you can see.
Sir, at very,
Yes,
can I say, sir?
yes, sure.
Sir, at very left side, there is spreading center. That's mean there is a divergent boundary.
Okay, right, very right.
Uh, that's why back or basin is forming there. And at the
Okay,
right side, there is a deep trench system. That means there is a convergent boundary. One plate is subducting into another plate.
okay,
And there are two basins mainly in convergent side. There's a trench basin right there in the deep sea trench, and there are four arc basin at land
okay,
side.
okay. What else?
So there are also volcanic island arcs due to subduction. They formed
Right,
at continental plate.
very right. What else?
So that's it, sir, from me.
Okay, anyone, anybody else? Okay, so we have majorly three types of basin present here. The first one is passive continental margin basin. This one is passive continental margin basin. And here we have the spreading center as these plates are moving apart from each other. This region from here until here is the back arc basin. And can anybody tell me that first I would like to tell you that there for a basin there should be walls on both sides of the basin. After if it have the walls, then it is called the basin because we need a depression area for sedimentation. So how we can say that it is a back arc basin?
Because, sir, it is on the back of the volcanic arc.
That is why it is called back arc basin. But volcanic arc is only providing one side wall for the back arc basin. So where is the second wall for back arc basin? Because this
But
one
edge
is
of the continent.
passive
Edge of the
continental
continent.
margin basin, but
At spreading centers.
spreading center. Very right. So how the spreading center is acting? Because when the spreading center opens up, the magma erupts on the surface. Is it correct?
Yes.
So when magma erupts on the surface, it provides the second wall for the sedimentation to deposit in the certain area. So the second wall for back arc basin is provided by the spreading center. When the magma erupted on the surface, it provided a wall for the sediments to deposit in the certain area. Here we have the volcanic arc, that is chain of volcanoes. We also have the four arc basin, as it is facing away from the volcanoes, and we also have the deep sea trench